Too many alerts and not enough action? It's time to get SaltStack. SaltStack is an intelligent IT automation platform that detects security issues in critical business systems and then actually fixes them. With SaltStack, security and IT teams work together to define custom security policies with certified checks for CIS, DISA-STIGs, and more. You can scan systems for millions of compliance checks in minutes. Remediate compliance and vulnerability issues with powerful automation, all in a single platform. Visit securityweekly.com/SaltStack to learn more. SysDig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using SysDig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. SysDig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using SysDig. To learn more, visit securityweekly.com/SysDig.
Welcome to Security Weekly. I'm your host, Matt Alderman. We are recording live day 2 of Black Hat 2019. We're in our suite at Mandalay Bay, and joining me for this interview is Cohen, co-founder and general manager for North America from WhiteSource.
Correct.
Welcome.
Hey.
You and I, yeah, it's good seeing you again. You and I did a briefing last year at the Pool Cabana. This year, like I said, we decided to come indoors and be a little cooler this year. But I want to get some updates on WhiteSource and kind of where you are. But before we go there, I'm a big application security fan, really. I see what's happening with digital transformation and how applications are changing and the use of open source and all the things that are going on, which is really interesting to watch. And I think it creates a lot of challenges.
Correct.
And so before we get into WhiteSource, what are some of the challenges you're seeing with open source software and the components of how software is being built?
So, the best way to describe these changes, and I have this dialogue with so many CIOs and CISOs, they look at their environment almost like a Swiss cheese, where those holes are the open source components. The only thing that they don't get or they don't understand or they miss is that they have more holes than cheese right now. So if you look at today's modern development environment, open source is used vastly. That's the right way to bring new stuff, new code to the market quickly, efficiently.
Right.
Why not doing that, right? But then if you have more open source there than your own code, and you have more eyes looking at the open source, finding more vulnerabilities, quality issues, but also fixing them, the issue of writing new code, genuine code, stops being how fast you can write line of code. It's more about how you orchestrate all those open source components, make sure that you bring in only the right stuff, kick out stuff you don't want up front at the gate, and once things are changing, prioritize, fix or change and replace very quickly to make sure that you maintain a secure environment, and qualified environment. So the shift from the need to write a lot of line of codes to the need to orchestrate, large group of open source components and make sure that all of them are in the right places, the right quality, without too many bugs and too many security risks. This is the challenge. And I think that this is the biggest shift that I've seen also in the entire market, where clients start to understand, without automating this process, without giving the right tool to the security people, to the DevOps people, even to the developers. They are the ones that do that. Who orchestrates that? That's not a CISO.
No.
That's not a CIO. It's the developer, right? So without taking care of all that, they will not be able to move on with, and continue producing more and more genuine code for themselves. So I think this is a huge change. It's hard to understand how big is this change, which is actually very positive, by the way.
Yeah, if we think about the old way of developing code, you had this big monolithic piece of code. It would take months and months and months to build or to get a release together. Open source has allowed us to speed that up. DevOps, cloud, all these components have allowed us to do this. And so you're right. It creates this. it's great for business and the speed of what business needs to do to get new features and capabilities out, but it puts security kind of in a bind because security is not used to a couple aspects, right? They're not used to the speed of deployment.
Correct.
If we think about traditional security, when I ever talk about this topic, I'd ask the question, how many people scan their network monthly, right? Bunch of hands go up.
Right.
Weekly, fewer hands go up. Daily, how about multiple times a day, right? DevOps allows you to potentially release multiple times a day.
Course.
So this environment's changed very, very fast. So, lots of people talk about shifting left and DevSecOps and all this other stuff. But at the end of the day, how do we get the right tooling to the right people at the right time to help ease this transition? And I think that's a lot of where WhiteSource comes in putting some of these tools in the developers and the DevOps hands.
Correct.
That also help security at the end, but they may not be used by the security teams. They're really being used by dev and DevOps, right?
So you'll be surprised. Okay. So we recognized this fact quite a while ago. The way we saw it is that under the model of software composition analysis, what is analysis? You do some work, you find you get a report, security report, compliance. What do you do with that? If you're a security guy, what do you do with that? You go to developers and beg for time to fix it?
You just hand them the report and go,
so
here,
what?
fix all this.
So,
Yeah, right.
and so what? They do other stuff, right? So obviously there's a need to shift the responsibility of fixing to someone else, those that write the code. But just shifting responsibility doesn't make anything. You have to give them the tools to do
Right.
that. And for the first time, and that's what we are so proud of, right? We're able to take all those policies and bill of material and information and prioritization that were on the right-hand side of the house, which is the security guys that
Right.
have a report, and translate it into real-time actions for the developers at their speed, at their time.
Right.
So we created what we call a web advisor that helped the developer when they go out and search for the first time for a new components to see if someone else is using it in the company, if this comply with company policies, if it has too many vulnerabilities, or even before they bring it in, they know it will fit or not. They still can bring it in because they may need it. There's no other option. Okay, so once they write the code now, same thing, in real time within their IDE or development environment, they will see immediately, hey, this version, this open source version have those vulnerabilities. If we pick the next one, it has less, and still they can bring it in. And if later on there will be some issue coming back, whatever, we push to them directly a remediation option. Click here and it will fix it by the latest fix, right? So these are the kind of tools that are at the hands of developers in their own environment. It takes the software composition analysis knowledge, policies,
but puts it into puts it into actionable things into their tool set that help them resolve it,
and they don't have to leave their environment for that.
Right.
So everything else is behind the scene. This is powerful. I'm telling you, this is going to change the way companies will write their code.
I think it will change a lot about the way we secure applications.
Of course.
Right? Because we've always done this at the end of the process, right? So development go off, build their code, do all their unit testing, then they hand it to security and they throw a SAST or a DAST at it or an IAST and they run all these tool sets.
Too late.
And they come up with all these vulnerabilities and then they go back to the development team. So, I got to fix all this before you go in production. That's not the way to secure the application.
There's a research that shows that on one hand, the number of vulnerabilities, open source and other vulnerabilities is growing year over year, but also on the open source side. But hackers know that companies will replace those very quickly. So they try to exploit new vulnerabilities as fast as possible before they are fixed. So that means that the IT have more work to do to track new vulnerabilities and less time to fix it. So without automation, without delegation to the right people, and you know what? Without giving them tools they like.
Yeah.
Developers will never take something they hate.
Yeah. And developers aren't going to log into a security tool.
Correct.
To go look at the report.
Correct.
For their application to go, I need to go fix these 3 things.
Correct.
If we're not giving that data back to them into their tools,
They'll never use it.
They're never going to use it.
And
I think that's a wake-up call to some security companies because every security company for years wanted everybody into their tool, their interface, right? They thought if they could create that stickiness of everybody coming into their tool, they wouldn't be that single pane of glass. It doesn't work in DevOps. That concept doesn't work here. The single pane of glass are the developer tools for the guys who are building it. It's not the security tool.
So these are exciting times. I seriously think that for the first time I can see security, operation, developers, as a hub and spokes, right? Can use the same repository of open source component, the vulnerabilities, the licenses in different ways by one company or one vendor that give them all the tools that they need. So for the security guys, we provide the report.
Right.
For the developers, we give them the real-time decision ability to take the right decision. For those that maintain, the automatic remediation, right? All these things. I think this is huge.
It's huge. Any updates recently from WhiteSource? I mean, you and I spoke a year ago at this event. Any recent updates that you want to share with the audience?
So we are keep on growing 200% year over year. The biggest change right now that we see, and also in the company-wise we did, was that we created a small team that the only thing they do right now is address the Fortune 1000. Because what we realized that, while we were able to hit the hardcore, the early adopter portion of the Fortune 1000, some of them are still lagging behind. So, and there is need to do some education, some explanation. So right now we proactively go out and invest time and effort in order to do that. This also allows us to do something that we'd never done before. As a company, we've always been able to be the innovators by the fact that we were talking with our clients, listening, and add all those feature functions. But we missed this portion of the market that never called us before. So this brings us, a total new kind of dialogue, of the majority of the market. This is a great feedback for us, give us new direction. It created some very unique roadmap features that, I'll have to kill you if I'll have to tell you that. Or
you can tell me later when they come out.
Okay.
We'll cover them on the show
these are extremely exciting capabilities, and we are trying to pitch it right now very directly to the right people. As I said, it helps us also to refine our own roadmap, and we see a great success in that. It's really. These are great time for us right now.
That's great. If people want to learn more about WhiteSource, where should they go?
They should go to our website. Under the content side, we have tons of stuff, almost on any area that you may wish and think about innovation, etc. But people can always call us at WhiteSource, software.com. We have this chat capability where people can ask questions. We have a lot of requests to participate sometimes in discussions. Large corporate want to put some strategy. You and I know that the book of how to manage open source security was not written yet.
Right.
With so many clients, we were able to gather that information. We are happily, share that knowledge with others. So, people just have to call us, and we'll be more than happy to address any question.
That's great. Ozzy, thanks for joining us.
Thank you for the opportunity.
Yeah, you're
always
welcome.
Pleasure meeting you.
Yes, that's always good. And thanks for watching. We'll return soon. Welcome to Security Weekly. I'm your host, Matt Alderman. We're at day 2, recording live at Black Hat 2019. We're in the suite at Mandalay Bay. And joining me for this segment, Jeff Hudson, CEO at Venafi.
Matt, good to meet you.
Nice meeting you. Yeah, last year you did this at the Pool Cabana with Paul.
125 degrees on the deck. It was insufferable. I was dressed like this. I wanted to be in my shorts, but I was kind of gentrified guy. It didn't work out so well.
That's why we're in the suite this year instead of down at the pool.
Thank you for that.
We learned our lesson very, very quickly and thought this was a much better place to be. This year we're going to talk code signing. And I want to start a little bit with the problem because, code signing is an important part of development, but there's also some risks associated with code signing. Kind of articulate some of the challenges or problems with code signing.
Sure. Let me give you a little context to put this whole subject matter in context with Venafi and why we exist.
Right.
How would that be?
That's perfect.
Okay. So you got to think of it as 2 actors on the network, people and machines. And people use usernames and passwords to identify themselves to machines. And then machines have to identify themselves to each other, but they don't use usernames and passwords. They use machine identities. And we know the number of machines is going through the roof. They all need identities. And we spend about $10 billion a year protecting human identities and just getting started protecting machine identities.
Yes.
And this is bad because Gartner points out all the time, 70% of network attacks will use stolen or compromised machine identities in 2020. And the number's just catching up to that right now. So we created the technology that protects machine identities for the world's largest, most digitally transformed, security-conscious companies. Now, the reason this is important and relevant is that a machine is not only a device, it's a virtual machine, which means it's software.
Yep.
It's a container, a microservice, a .exe, an algorithm, code, blockchain. These are all machines, and they all have identities associated with them, whether they're SSL, TLS certificates, whether they're SSH keys, or code signing keys. And so this is where we intercept with it, because in the world's new corporations, it's all made of code. These things are all code.
Yeah. Everything's just code now.
Everything's code. Everybody's coder. So when you create a machine out of code, how do you know you trust that machine? How do you know it's your machine? How do you know where it came from? And how do you know what it's going to do? So the practice has been, over the last probably 15, 20 years, that you sign the code. And you sign it with a code signing certificate. And what that essentially is like a birth certificate for a piece of code. And so you put it on there, and then you know the provenance of it, you know where it came.
Right.
And because of the magic around that, you also know if it's ever been tampered with. So it was certified good at birth if you go through the process, and then you can tell if it's ever been changed, which is like critically important, because you got all these people running around writing code now, and it's starting to execute on behalf of the corporation. How do you know if you're a corporation, how do you know it's my code? How do I know if I want it to run here? And this is what code signing is about. So that's a basic primer on code signing.
So I'll give you a great example, because Paul did this. He left the API open to the Kubernetes environment up in AWS. And next thing we know, there's a new container up running on our Kubernetes cluster. Right? Yeah, I didn't want that there. Right? And that is a very valid use case of why signing is important, because if I had the machine, if I had my signatures, my code signed in my containers, and it knew that it was supposed to be on that Kubernetes cluster, for example, and they knew those identities, then the ability potentially for somebody to drop a new one on there could have been blocked or stopped, or at least
that's
something.
The whole point.
Yeah, exactly. And when we see this proliferation of containers and containerization in cloud, and we're taking what was once a big monolithic application written in a single language, and then
break it up into
lots of pieces with lots of different languages on lots of different areas. I mean, it could be running on-prem, it could be running in Azure, it could be running in AWS, Fargate, ECS. The list goes on and on and on. This problem is only exploded and expanded.
The complexity has just gone through the roof.
Correct.
And what we typically think about a web app, where you click on things and you go to boxes, that used to be monolithic, one web server. And now there might be 100 web servers involved in that. So you click here, and to get the customer number, it goes there. To get the balance, it goes there. To get your history, it goes there. All this in there can be everywhere. And so it's like, okay, how do we secure this thing? And it starts with the code that you run, you can trust it.
Right.
And the way that programmers do this, and the way they have done it, is they will either, in all development environments, have a code signing capability. So you can sign code.
Right.
So the developer will go get their own certificate, or they'll go to, GoDaddy or one of those places, get it. They'll set up their own little vault, and they'll sign the code, right? Well, then where's the key? It's on the developer's laptop, right? And so you got a whole bunch of developers doing that. The upshot of that is those things are easy to steal. And so there are about 22 million pieces of malware out there in the wild right now that are signed with stolen or forged code signing certificates. Because, like you said, if it's got a code signing certificate on it, if it's signed code, the first check is it signed or not? Yes or no? Do I trust the root on which it's signed? Yes or no? I do. It's a stolen certificate. Nobody knows. Let it run, and it's malware. And so there's the big problem.
Right.
There's this thing called key sprawl, and the developers of the world, these keys are like everywhere.
Yeah.
And so InfoSec is going, oh my God, we're creating all this code. It represents, it's like Intel or HP or whoever, and it turns out to be malware. Reputation problem, all kinds of problems.
Right.
So that's one of the problems. The other problem is, I mentioned that developers want to sign their own. So they go get their own certificates and they set up their vaults and their own little workflows. Why are they doing that instead of building apps that build value for their organization?
Right.
So there are the two problems. One is this thing slows developers down. Oh, by the way, there are some code signing things out there where you upload your code. So you upload, a big piece of code and it will sign it and do other things and bring it back down. That could be a day or two, right? And so this is old school. It's it's
old
all
school.
what used to happen.
You don't wait a day or two because people are releasing code like multiple times a day.
Multiple times
cases.
a minute.
Yeah.
Yeah.
Depending on the organization.
Right.
But I mean, the days of waiting days or weeks are gone in this space because people are releasing code daily, if not multiple times in a day.
Right.
And so you need tools and processes that can keep up with that speed.
Well, and your earlier point was there was a monolith and you had a make and build process to build the monolith, and you release the monolith. But now what we've done is disintegrated the monolith or fractured it into millions of little pieces. All those things need to be signed. And all those little pieces change all the time.
All the time, yeah.
And so there's the big problem. Developers are going too slow and the keys are sprawled everywhere.
Right.
So we saw this problem because we're smack in the middle of machine identities.
Right.
We saw it about 4 years ago, and we've been working on it ever since. And so we just introduced something called next-gen code signing. And what we've done is created something that we've patented, which is a way to create a really cool cryptographic service, a CSP, where when the code signing engine that wants to sign the code needs a code signing certificate, it reaches out to our API.
Okay.
And what we do is we sign a hash and send it back. And then this hash gets associated with the code. The code doesn't have to move. The developers don't have to think about it because it's in their pipeline.
Right.
And the security guys know where all the code signing keys are.
Got
so
it.
it helps the developers go faster and it eliminates key sprawl. And so this is like huge because now everybody's a coder and everybody's saying, well, how do I sign code? And the InfoSec teams are saying, well, we'll send you code signing key. It just doesn't work. So we solved those problems.
So is it something that you embed into the IDE or into the build system? How does it actually get to your service? It's an API, but
it's an
from
API
a deployment perspective.
It's an API call. We have all kinds of different ways that it gets interfaced. So they call our API, embed a snippet. There's some open source stuff, all this kinds of stuff. But the point is, the Windows, the Java, you look at it, the Go, all those development environments, they've already got code signing built in.
Got it.
They just don't know where to get the key.
Yeah.
And so what they do is when they need the key, they call out
us.
to Venafi.
Got it. And then you have all the keys centralized, so you know where they all are.
Right.
So security's happy because all the keys are centralized and they're not sitting on
They're
developers' laptops.
They're auditable,
Yeah.
all auditable.
Devices, yeah.
Right. You can and so if something shows up in the wild with a signed as, say XYZ Corporation, and corporation says that's not ours, say, look, we didn't sign it.
Right.
So it's really important.
But it also helps with key revocation, right?
Totally.
Because if a key does get compromised or something happens and you need to revoke it, you can do that easily if it's all centrally managed and housed versus trying to figure out, okay, where's that key at, right? Whose computer is it on?
Or if you want to set up your system so that they'll only execute code that's signed by you, then what you have to do is you have to have really good control over those things. You have to be able to check back and say, is this valid?
Yeah. Are they still valid?
Yeah. So all the problems that exist around an identity. So if you have a driver's license or a passport, they may expire or you may need to expire them.
Right.
Or you may find something where you didn't expect it to be, so you better expire everything and reissue it. There's all kinds of things. There's so many corner cases in identity.
Yes.
And we need to think of machines, code as things that need identity, just like humans do, machines do. And that's the only way this world is going to unfold in a way that we can trust it.
Yeah.
Because right now more than ever, machines are making real-time life and death decisions about you and I, not in Syria and Afghanistan, but on the streets of Las Vegas. Because if you think of a self-driving car going down the road driven by what? A machine, a piece of code, and a truck pulls out in front of it unexpectedly, it's got less than a millisecond to decide, do I crash in the truck and kill the occupants of the car, or do I swerve on the sidewalk and kill the pedestrians on the sidewalk? It's not going to check back with anybody. It's not going to ask a human. It's going to make that decision. So that code, how important is it that we know where that came from?
Right.
That code has an identity. It's the one we expect to be on there. We know what ethics and morals were brought to bear to code those kinds of decisions now that machines are making life and death decisions. The identity of these machines is skyrocketing in importance, and it's still not something that's on most people's mind.
Yeah. No, Bruce Schneier brought this up at InfoSec World earlier this year about the need for this, that certificates and the ability for machines to communicate to other machines and create those, that authentication is going to explode. And you're talking about the same things. We're just expanding that concept of a machine all the way down to the individual pieces of code that are embedded in your application that need to communicate to other components.
That make up the application.
Yes.
Yeah.
Yeah, because there's so many components now embedded in these environments. You're pulling down containers that already have all these binaries and libraries embedded in them, and then you're building your custom code on top and understanding all those pieces and who signed them when to make sure that they're still the right.
And think about devices or machines that get embedded into humans, whether it's a pacemaker or an insulin pump or many, many things. You're going to want to know that the code that's running on that is actually the code that you think is supposed to be running on that. And therein lies, again, the importance of and the power of having an identity. And once you have an identity, we know it wants to be stolen, so you better protect it.
Right. So when I think about value to the customer, I mean, obviously visibility, figuring out where all your keys are and making sure that they're all centrally managed. You talk a little bit about developer friendly, and I think that is just, it has to be easy for development. Otherwise, it's not going to get adopted.
So have you read the book, The Phoenix Project?
I have not finished it.
You've got to read it.
Yeah, I know. Paul's read it, and he talks about it all the time.
Okay. So anyway, there's a persona in there that's a CISO. They call him the Minister of No, John Pesci. And everybody doesn't like him because he slows everything down. And so InfoSec has always been sort of the enemy of go fast, because they always say, no, go slow. So what we're doing with our InfoSec teams around the world, and we've probably got, close to 400 now of the world's largest corporations, all the big banks on 5 continents, all the big airlines, all the big card companies, everybody that's really moving into digital transformation. We're saying, set up a service. Become a service provider to your customers, and we provide them the ability to completely automate everything that has to do with certificates and keys, machine identities for DevOps, for things like F5s, for now code signing. So set up the service, hang out the shingle, say it's available here. And then what happens is when somebody says, yeah, I don't want to do that, then you just give them the policy manual. Say, okay, do it yourself. I'm fine with that. Fill your boots. There's the policy manual. But you're on your own. Or use my service, and then I will take care of the auditors, and I'll take care of all that stuff. You'll go faster. I'll be safer. I'll be happy. We're in it together. So set up a service and give people a choice. And it's actually working. And so it's fun to be able to help InfoSec teams become a partner
with
to
the
help
business,
people to go fast,
and not the prohibitor.
The Minister of No. I love that. You should read finish the Phoenix Project. Really good book, because it talks about what I call religion and philosophy of DevOps. Right, and it's a different way of thinking.
Yeah, definitely. If people want to find out more about your new code signing capabilities, where should they go?
Go to Venafi.com, www.venafi.com, and it's very straightforward of how you learn about the outcomes that we give to people, like help them go faster or avoid fraud and misuse or avoid outages. Outages is a really big thing, and it's really a good way to learn about this part of the market. A lot of people, it's really interesting. Go to some of your friends and say, do you know how a toilet works? And they're all going to say, I know how a toilet works. And they say, well, explain to me how a toilet works. And they don't know, right? What happens is a lot of people think they understand stuff, but they know somebody that understands it. And so they'll say, well, in their mind, I know that person, so I get it. Or it's on Google, right? But they don't get it. this is where this is. People don't understand the importance of protecting machine identities. So go to our website. You can learn a lot more about it.
Awesome. Jeff, thanks for joining us.
Matt.
Thank
Really
you.
appreciate it.
And thanks for watching. We'll see you soon.